A natural question that arises at this point is, can m be a fraction? Let us answer this question through the following example. Sam is driving his new bus. The bus has a mileage of 2 kilometers per liter, which means after every kilometer, half a liter of diesel is consumed. Sam had started the journey with 5 liters of diesel. How much diesel would be left after a given number of kilometers? Now the given number of kilometers is a variable, it may vary, so let us call it x. We are supposed to find how much diesel would be left, so let us call that y. So y equals, well, he had started with 5 liters, so 5, and because after every liter, after every kilometer, half a liter of diesel is consumed, that means after x kilometers, half times x liters of petrol would be consumed. Now if this is the amount of diesel consumed, the amount of diesel left would be 5, which is the total amount of diesel, minus half x. Now I can just swap the two terms and this becomes y equals minus half x plus 5. That is my equation for this problem. Now let me write that here clearly, getting rid of all of this. Yeah, y equals minus half x plus 5. If we look at this example, this is the y-intercept and this is our slope, which is m. So technically we can see here that m can be a fraction. Now let us see what exactly a fractional m stands for, or what it really means. Here I have a graph and I have plotted this equation on the graph. I can see that this is my y-intercept, which is y equals 5. This point is 5. So yeah, that is pretty accurate. Now after a kilometer has passed, let's say we go from 0 to 1. This is 1, right? You can trace it down on the x-axis. This is 1, and just to remind us, on the x-axis we have the number of kilometers. I'm just writing km for kilometers. So after I go from 0 to 1 kilometer, or after the bus has traveled a kilometer, the fuel or the diesel goes from 5 liters to this point. This point is between 4 and 5, so it is 4.5. So it has reduced by 0.5, and again after another kilometer it again goes down by 0.5, right? It goes from 4.5 to 4. It goes down by 0.5. So after every kilometer it keeps on reducing by 0.5. So essentially the rate of consumption of diesel is 0.5, which is m, right? 0.5 or half. So essentially this fractional m simply stands for a fractional rate at which the y value is reducing or increasing. Here, because I have a negative fraction, negative 0.5 or negative half, it simply means that the value of y is reducing. That reducing is denoted by this negative sign, and 0.5 or this fractional value simply tells us that the rate is fractional, or it simply means that after every 1 unit in the x direction we simply move a fractional unit, a fraction of a unit in the y direction. It is going downwards because it is negative. So that is a simple meaning of a fractional value for our slope, and negative and positive I hope you've understood. Let us look at a few. So these are the various points, and you can just look at how after every unit the y value is reducing by 0.5 units, right? So that is the simple meaning of a fractional slope. Now let us have a look at a few more examples to really reinforce the idea of a slope. Here I have y equals 1x plus 0. So the for simplicity's sake, the y-intercept in all the cases is 0. I have 1 as my slope. What does that mean? 1 as the slope simply means that as I go 1 unit in the x direction, the y value also increases by 1 unit, right? 1 unit in this direction, it also increases as 1 unit. Now furthermore, I have here y equals 4x plus 0. If we compare the two, what is the difference? Well, the difference lies in the m value, or the slope value of the slope. This has a higher slope, and that can be clearly seen in the graph also. This graph right here, this graph, it is much steeper than this graph, right? So it simply means that the higher the slope, the steeper our graph becomes. Steeper, sorry, the steeper our graph becomes. I'll write that clearly. Wait. Yeah, right. Steeper. So here our slope has increased and the graph has become more steep. So it's like you can imagine a person on this graph who's walking in this direction, and a person on this graph, and you can clearly see who is going up a steeper mountain. So essentially you can look at this graph as a mountain, and the slope value, or this, the value of m, really tells us how steep this mountain is. If I look at more examples, a fractional m really means that this slope is really low, it's lower than 1, so the graph is not really that steep. See, it is much less steep than when I had the slope as 1, right? Here the slope is pretty steep. Here, because my slope is 0.1, it is less than 1, the graph is also not as steep as the previous case. Here I have the slope as 0.5, so it is slightly more steep than this case where the slope is 0.1. So you can just compare the two. Here I have slightly higher, a slightly steeper graph as compared to this one. So I hope you get the idea, right? As the slope value increases, the graph becomes steeper, and when the slope value gets 0, the graph becomes flat. The graph has no steepness, it is flat, like so. You know, it is like complete flat ground, and you can walk on this pretty easily. Now when I have a negative value for my slope, -1 or -4, it simply means that now I have a downwards pointing slope. You can imagine yourself standing on this, and as you walk in this direction, it'll feel as if you're going downhill. Now the higher the number, higher this value is in the negative direction, -4, the more negative that this number becomes, the steeper the slope gets, the downward slope gets, right? So this is even more steep in the downward direction, right? If that makes sense. This is not as steep as this case where I have my slope as -4. It is very steep in the downward direction, whereas this one where the slope is -1, it is not as steep as the other case. So yeah, that is slope for you, represented by the letter m.